What is going on, everybody? Welcome back to another video, Code 1. So today we're going to knock out another array question, which is essentially given an array, what is the most frequently occurring element within that array? So this is going to be done in linear time, so a big O of n. Essentially what we're just going to do is create an empty dictionary to keep track of the occurrences, and then we're going to return the element with the largest maximum count. So nothing too monstrous today. So we'll call it most frequent, and what are we passing? We're going to pass through a list into this function. Of course, we want to create our count. Like I said, that's going to be an empty dictionary. All right, so the empty dictionary, we want a key value for the count, and we're going to set our max count. We'll set it to 0 for right now. We're just initializing max count. That's going to keep track of the number of times each item has occurred. And then we're going to have a maximum item, which as of right now is going to equal none because we don't have any. The max item is just another variable. It's going to keep track as a counter in real time for the most frequently occurring item that we have thus far. So for I in list, we're just going to iterate through the list that we're given in the argument for the most function. If the I is not in the count, well, what do we want to do? If the I... For I not in count, we want to index an index item that has not been saved yet. That's what that is for. I have not in count. If it's not in count, count right now is empty. So if it's not in count, we want to do something with it. We want to index it. We want to put that element in count, and that element's going to be I at that moment, right? And we want to give it a count of 1. So we want to actually, whatever the element is, if this list has an element 2. And if there's no 2 in count yet, then we want to add 2 to this empty dictionary called count. Else, so we're going to jump down, and we're going to throw our else in. This means we have to see, we also have numbers that we've seen before. So if we've seen the number before, what do we want to do with count? Well, we want to add to it, right? So now we have a way that we've seen a number before. We can add 1 to its value in the dictionary key. But what if, not what if, but rather we also have to, we're also going to have to, I'm just trying to make sure we have max count, max item. So now we have to go through our max count and max item and see if they need to be adjudicated as we go along. So the, this will make sense. If count of I is greater than maximum count, this is comparing the value of the elements in the dictionary to the maximum count. So whatever value in the dictionary we've built in this loop, we're comparing it to the max count for that particular I. All right, nothing monumental there. So if the max count of I is greater than max count, we want to update max count because it should be the maximum count, right? So we want it to be the count of that I so that it updates the maximum count. We want the maximum count to reflect the maximum count for that particular key in the dictionary. And then of course we also want to update if it is so, it's the new king of the max location. So if max count is updated, then that max item is also going to take the cake for right now. So all of this is doing is just updating these 2 variables here as we go along, iterating through our list. And then simple as sweet, we want to return what? Not the max. Whole point of this is to get the maximum item, right? Given an array, what is the most frequently occurring element? We want to return the max item. So no errors showing up yet. We have call our why are you, oh my goodness. I really should have my coffee first, shouldn't I? We're going to open and close, and I'm also going to open and close the function out just so we're consistent. And now within this, we're going to be passing a list. I'm going to put that list in. So let's say we did 1, 3, 3, another 3, a 2, a 1, a 1, a 1. So we can tell that we should get a 1 as our output. But I wanted to have the 1 after the 3 because I don't want it to be numerically validated. And you should be able to do negative numbers in this as well. So let's see what we're going to rock here. So we have a 1. All right, so that worked. All right, so we can debug through this. I'm just going to, argument's sake, I'm going to increase it to 3 and run it again and see if we get 3. Okay, cool. So let's close that out. And get rid of a 3 so we can keep it a 1, because I like the idea that it's value-wise is less than a 3 and it's after the 3. So make sure that we're actually iterating properly. So let's debug through this bad boy. Not going to need you. We're going to go down to our print, get our list. Now we have our list in memory. Count is an empty dictionary in memory. Max count's a variable set to 0 in dictionary. Max item is set to none. Now we're going to iterate through the list. So I is going to be 1, because that's our first element in the list. If I is not in count, count right now is empty, so it's not in count, so that's going to be true. So we want to increase that to 1. So now it's going to say 1:1, because it's a dictionary. So now we have one occurrence of the number 1 so far in our count. And then we're going to if count I is greater than max count. Well, max count is 0, so that's true. So it should update the maximum count to 1, and the max item we're going to update to whatever I is at that moment. I right now is 1. So now we have our king of the hill is max item is 1. Now we're going to go through the next number, so it should be 3. So we're going to go through 3. It's going to add it to the list. Max count is greater than max count. Nope, it's 1. So 3 has an occurrence of 1. 1 has an occurrence of 1. So there was no update to be done. Now we're I in list. Now we're going to know we have the number 3 again. So count was in there, so now we're going to hit the else loop. So count, just increase it by 1. So this 3:1 should become 3:2 when I go through this line. Excellent. If count I is greater than max count is 1. Count of I right now is 2. So this max item here should change to 3, and the max count should change to 2. 2 and 3. Excellent. And all we do is update the max count to be count of I and the max item to be I. And we're just going to keep going through this. We have 3 again. Now we have 3 3s. So the max count was updated. Max item was already 3. Now we have a number 2, but number 2, which was never seen before, so it created the key value of 2:1, but it did not. The max count right now is 3, so 1 is less than 3, so it didn't have to go through this code down below. And we're just going to keep going. We're going to get our 1s. Now we have 4 1s. So now max item right now is set to 3. Max count is 4 because I1 is the 4. So max count 3 should change to 1 right now. Excellent. So now that we're going through this, let's see. So we went through the whole for loop. Now we're just going to return the max item. And that would have been the number 1, which we have. Let me go to floating mode. I should just do that automatically. Which we have is the number 1. And if we wanted to make these, the negative's not going to make a difference because it's checking the occurrence of each particular element. It's not checking the numerical value of it. So you can see that we have -1 as the return. So another quick function just to show us how we can utilize lists, for loops, iterations, if loop, else loop, and just creating some variables inside that will create a counter. So you'll notice a lot of what we've been doing in a lot of our array problems, we're creating counters or creating pointers to iterate through arrays, or we're creating counters in dictionary style. So we have a key value count to go through this. Equally enough to find the least occurring element in a very similar fashion, which we've done before. So we have most frequently occurring element, and we've done least as well. So with that said, guys, enjoy the code, and I'll see you in the next video.